In this session, we will discuss a brief on agentic framework. If you have started exploring this space, you might have noticed that there are various frameworks, and each framework is very promising and probably run into the same question as I did. What is the difference between all these frameworks? How do their approach actually differ? And as a developer or a tech lead, how do I guide my team or decide which framework fits my requirement? So let's get some understanding that can make it easier to pick the right one for whatever use case we are trying to build. So agentic AI or agentic approach, it is opening up some really exciting possibility. We can now build systems that don't just respond but actually reason, plan, use tools, and even make up teams to solve complex problems. And it is very positive that problem solving using agentic approach has very strong case, and it is going to become a norm. So, for this discussion, uh, we will be looking at the five popular frameworks, and they are OpenAI SDK, AutoGen, CrewAI, LangGraph, and Google ADK. These five have gained significant traction and are being adopted by enterprise, making them worthy for deeper dive and exploration. So now let's get in details. Core part of the framework is open source, but their enterprise version, which offers operation supports, might be paid version. But we will focus on the framework from the perspective of a design and code. So at first glance, they look pretty similar, especially if your main goal is just to plug into an LLM and get going. But once you dig in, you will see that each one takes a different angle and offer its own strength. So I have pulled together some of my learnings that might help you get started or uh, just get a better feel of what is out there. So we will start with a quick overview of each framework, take a look at how they tackle a specific problem or workflow, and then jump into some code example to see them in action. I would like to clarify that our approach will emphasize on the strength and unique inclination of each framework. The goal is to understand which framework is best suited for a given type of problem or situation. While many problems can be addressed by multiple frameworks, our focus will be on appreciating the distinct approach each one takes. So now let's get started with Open SDK. The Open SDK takes code first and abstraction minimal approach. So instead of enforcing prescriptive patterns or a heavy abstraction, it gives you just what is needed to get started and keep abstraction minimal. So as a developer, of course, you can you can build a simple solution with a few lines of Python code. So although code first might sound like counterintuitive since we are used to hearing terms like no code, but in this case, code first and minimal abstraction is saying that do not complicate or use heavy abstraction if it is not really needed. So OpenAI SDK, it is a light, lean, and encourages you to work directly with LLM APIs and if not required, you don't use any extra layer of abstraction or hidden complexity which comes with a framework. So it is like just your code, your logic, lightweight mechanism to connect to LLMs. Now let's discuss AutoGen. AutoGen takes approach of message-driven conversational frameworks for building collaborative agents. Imagine building a system where agents do not just run tasks; instead, they talk to each other like teammates. One agent can act like an expert planner, the other can be a designer, the other can be a coder and a tester. The strength of these agents, like they behave more like autonomous and collaborate to meet the final objective. And rather than taking a prescriptive workflow approach, the team of agents can take an entire objective and then work out its way based on the context. I mean, they adapt to the context, they exchange messages in the terms of questions, they share results, and ultimately they achieve their final objective. AutoGen Core, uh, which is a core of AutoGen framework, uh, it supports asynchronous event-driven design, request response pattern. So you get the flexibility to dynamic workflows that evolve in real time. Now let's focus on CrewAI. So CrewAI employs role and task-based structure. Each agent is given a clear role, goal, and backstory. So a combination of a role, goal, and a backstory guides the agent to tackle the task. Tasks themselves are atomic units. And when I say atomic units, they are well defined and they are assigned to the agents. And and these tasks also have expected output and the tools. So the agent knows exactly like what it is expected out of it and what tools it can access to uh, like a fetch more informations. So CrewAI approach will be very beneficial when you want to structure and mirror a well-defined workflow. This makes CrewAI a powerful fit for predefined goal oriented workflows where clarity and collaboration both matters the most. So let us take one example. In a typical software development cycle, like we know like that like every team member has a predefined goal and objectives and the success criteria are known. So if you want to automate a software development life cycle, so for such use cases, Crew AI stands out. So now let's talk about LangGraph. LangGraph uses a graph-based architecture where nodes represent a function or agent action, and edge defines how data and the control moves. Think of building an AI agent system like drawing a flowchart. From a diagram perspective, I think the best diagram I could see was the one which is on a LangGraph site. So if you can see here, the the starting point is basically a start. You can tell it as a node where your graph flow starts, and the box i- in the green which is written here like an LLM. So this is a node where the function basically makes the call to uh, LLM, And next circle, you can say it is another node which has set of tools, and our LLM can conditionally call tools based on the needs. So now, the power of LangGraph comes like, since it follows a graph-based structure, uh, it can solve many complex tasks like the certain flows which can iterate, but at the same time, conditionally, it can take multiple paths. So, and the line graph is basically stateful by design, meaning the agents can track and update shared context across the entire graph. That makes it for a perfect structured multi-step workflows where it can loop, it can act like a decision tree, or it can coordinate with multi-agent systems. Now let's talk about Google ADK. So the strength of Google ADK lies in its easy integration with ecosystems. Let's say a requirement is getting agents to work inside your existing architecture. I mean, the existing system, which is already serving a business value, and now you want to extend it with AI agents. And since you are going to extend the existing system, you don't want to redesign or bring complexity to the system which is already delivering value. So instead, you are looking for approach which which can simplify and integrate easily with a minimum code with uh, the existing ecosystems. So, in a simple terms, you want something which can be plugged into your existing architecture quickly and cleanly with the minimum changes. So that is where Google ADK shines. Uh, so Google ADK, very similar to OpenAI SDK. It is lightweight and code-first approach with the minimal abstractions and prescriptions or predefined flows. But its real focus is on integration, especially within Google Cloud Platform. Okay, now let's go through a couple of simple use cases and basically improve our understanding. So the first use case we can start is a company wants to automate a custom financial analysis pipeline that integrates proprietary algorithms, retrieves real-time market data, and generates tailored investment reports, requiring high flexibility in the workflow design. So, as a developer and a tech lead, we should be first looking at the design factors. So, according to me, the design factors are a proprietary algorithm, which means like the organization does have well-defined APIs and algorithms, and then market data. This is where our LLM comes into picture, where it should be able to use tools and go to open market and get certain reports or make some r- researches. And tailored report, it moves it looks more like based on certain portfolios or business requirements. The reports should be like a uh, driven based on the audience. So we can use LLM based approach for this requirement also. And the next comes highly flexible. So basically, it is saying like avoid unnecessarily abstraction, keep things simple. So for this use case, I think uh, OpenAI Agent SDK is a good fit because it is lightweighted as well as it keeps things simple. So now let's jump to the next use case. So our next use case is a company wants to build a scalable customer support system where AI agents handle in initial inquiries, collaborate to resolve complex issues, escalate to human agents when needed, prioritizing conversational flexibility. So here, if you see, the key design factors are conversational and collaboration. And so you can see like the requirement is somehow inclined towards a conversation and a lot of message exchanges. So to me it looks like in such situation, the inbuilt generic abstraction provided by AutoGen, uh, and which is also a message oriented, and you can easily build autonomous. Here I'm using the term autonomous because uh, when the agents are communicating with the customer service, it means like based on the context, they should be able to adapt to how to reach the final goal. So there will be a context. There is no well-defined path to reach the final uh, o- objective. So it will be more like a autonomous, collaborative, and message exchange oriented. So to me, it looks like AutoGen is a good fit. Now we go to one more use case. A technology company aims to automate SDLC process, reduce effort, lower cost, accelerate MVP creations, requiring a structured role-based workflow approach. So for this requirement, if we see the design factor, it is mostly inclined towards mirror human team dynamics, predefined roles, tasks, and workflow do not need in-depth or collaborative conversation between multi-agents. So this looks like it is a very good fit for a CrewAI, because the strength of CrewAI is when the requirement is based on the role, tasks, and there is a well-defined, predefined flow success criteria, right? So, and now we'll jump to one more use case, which is on the LangGraph. So, a research team needs a system to automate literature reviews where agents iteratively search, summarize, synthesize academic papers, maintaining context across multiple steps and handling non-linear workflow with decision points. So, from a design factor, uh, it appears like it is multi-phase, iterative, stateful and modular design, and most important, like we should have a proper decision points like a decision tree. So LangGraph will be a better fit because LangGraph does follow a graph structure, and with the power of a graph structure it can solve any non-linear complex tasks and also easily facilitate decision trees. Now let's go to the last use case. A logistic company seeks to build an AI agent system to mirror supply chain data in real time, integrating with external systems like ERP, weather API, logistic platform to optimize operations with minimum custom code. So clearly, this use case is very much inclined towards integration with ecosystem, and most important, the systems or the architecture is already existing, it is operational, it is serving value to the business, so with a minimal change or minimum a code. If the integration can be achieved, that will be the big success criteria. And in such case, of course, Google ADK turns out to be the best. So that is all uh, I had to share in this video. And uh, I have a couple of videos with code which will help you to get started. These are few links which will help you to further improve your understanding about agentic frameworks. And if you liked my content, please subscribe, and your valuable input suggestions are most welcome.